One of the things in Quant that I think students think they remember entirely more than they actually do is balancing chemical equations, naming, stoichiometry, forming ionic compounds. And so I want to remind you in this video of the concepts that go behind all of that stuff I just named. So for instance, right now we have this compound here. So what is the name of that? So NH4, remember, is a polyatomic ion, which means it's a group of atoms covalently bound together that have a charge. And so that charge allows it to ionically bond with another atom or molecule. In this case, it's bonding with carbonate, which is another polyatomic ion. And so your carbon is bound to your oxygen, covalently bound together, net charge on that compound. So when carbonate, with its 2 negative charge, bonds with ammonium ion, which has a +1 charge, you're going to need two ammoniums to balance out the one carbonate. Okay, so polyatomic ion, they're bonding through an ionic compound, through an ionic bond. Here, you have your lead and your nitrate. Now remember, lead is a transition metal. It is a type 2. And so when you're naming type 2 ions, you have to tell me what the charge is. Why? Because lead has 2 oxidation states. It has a 2+ and a 4+. And so when we're naming this compound, we know nitrate has a -1 charge. And so since it has a -1 charge, this means that lead has a 2+ here. And so this becomes lead 2 nitrate. So in naming them, we would label them as like ammonium. Ammonium is the ion, so ammonium carbonate. Ammonia is the gas, NH3, carbonate. And then this is lead 2 nitrate. All right, so that's the first step, is naming and figuring out what compounds are in them. But then also, how are these formed? So remember, when we've got ammonium, we have NH4+, and carbonate, CO3 2-, lead 2+. Remember, your cations, which are the positively charged species, are written first, and then the negatively charged species, which is called your anion. So your nitrates, NO3 negative. So whenever we form these compounds, we are crossing the charges. That's what I call it. And so your positive comes down, your +1 comes down here and forms this kind of understood 1 outside of carbonate. I don't write the understood ones. You're welcome to do so. And then the 2 becomes this 2 that you saw in the formula for ammonium carbonate. And so that's where you'll ever hear me say, cross those charges. That's all that means. Because then this becomes NH4 with a 2 outside of it and carbonate with a understood 1 outside of it. And they do the same thing here. And so that's how I knew that my lead was a 2+ as opposed to my 4+, because if this were a 4 outside here, it would have been 4+. But now what do we do with this? How do we predict the products of my equation? And so I'm just going to react them, how they would form if they were put into water, and then find the different ions. So in order for me to do this, this is going to assume that this is aqueous, and this is aqueous if I'm going to put them into water. So what do I mean by aqueous? Ammonium ions are highly soluble, so are nitrates. Those are very soluble, if you remember your solubility rules. So you throw them into water, they're going to force these guys to come apart, these guys to come apart, and now they're free to go and find other species that might be interested in bonding. So if another positive finds another positive, so if my lead finds my ammonium, they're going to repel because they're both positively charges. Same thing for carbonate and nitrate, repel. But if my ammonia forms with my nitrate, they're going to find and they're going to stick. And maybe momentary, and they may fall right back apart, or they may stick and form a solid. And then carbonate and lead is going to do the same. And so if these form, what compounds are formed? So we need to do what we talked about a second ago, which is crossing those charges. So we have NH4 reacting with my nitrate. So these two are going to react, and then also my lead 2+ is going to react with my carbonate. So when these two react together, I'm going to cross those charges and form NH4. I'm going to put my parentheses around there just for me, NO3, and then my charges are not written in the final product. And my next one, I got to cross those charges. But when I cross them, this 2 is coming down here, this 2 is going to come down here. And then you report it in its lowest common form. And so the 2's are essentially going to go away and reduce down to be 1's. And so I end up with lead 2 carbonate, which is just written like that. So now to finish out my reaction, I'm kind of ran out of room going right, so just assume this half This is the first half of my equation, and then this is my second half of my equation. What are my states here? Well, ammonia, is very soluble, so is nitrate. So this is going to be aqueous. And then lead carbonate, that is going to be insoluble. A lot of your carbonates are not soluble, so especially if you mix them with the transition metal. And so this one is going to be your best guess if you had to guess, and that is your solid substance. Okay. So what did we learn here? We remind ourselves about polyatomic ions, remind ourselves about ionic compounds and how we form them, predict products, remind ourselves a little bit of solubility. All of this is built into balancing. Now in quant, we're mainly working in the liquid state. Okay, we're not doing a whole lot of just creating synthetic compounds from mixing compound solids together. So a lot of ours is in the aqueous phase. So in this case, we need to think about what are spectator ions, what is the net reaction. So when we're talking about net reactions, it's what if this stuff formed my compound? What compound do I care about? Well, this is the only real compound that's formed. What do I mean by that? If these are aqueous, that means that my ammonia and the ions are still floating around in water. So are my nitrates. And so if they're still floating around, all of this is happening, but this is the only new thing that's formed. It forms, it sticks together. That's why we have a single right arrow forming to the right. And so my net compound would then, of course, be lead 2+ plus my carbonate yields. I ran out of room, so I'm going to come just below it. Lead carbonate. That looks like that. And so this is my net reaction. I put my states in here, aqueous, and solid. This is what really happens. This is the reaction I care about. All the other stuff, normally your group 1, cations, those are just spectators. And so ammonium and my nitrate, those are my spectators. And so we need to be paying attention to what's happening and why, but then also what is the equation? Because a lot of times students just don't write out the chemical reaction, and if they would just write it out, they would do fantastic. So that is your first idea, is the balanced chemical equation and all the stuff that goes into creating that net reaction.